Hello students, good morning all of you. Today we are going to discuss about the topic that is the mechanism of the opening and closing of stomata. Opening and closing of stomata. Okay, so we already discussed about the structure of stomata. The stomata, it has a pore which is guided by the two kidney shaped cells. Okay, the inner wall of the stoma or inner wall of the guard cell, it is thick. Okay, and the outer wall is thin. This kidney shaped guard cell, it has the central large vacuole. Okay, it has a central vacuole. It has this guard cell, they have the nucleus and the chloroplast with the starch. Okay, chloroplast with the starch. So these are the it is the stoma or the pore which is guarded by two kidney shaped guard cells. Okay, these guard cells, they are again surrounded by the subsidiary cells. They are surrounded by the subsidiary cells, and the subsidiary cells, they are again surrounded by the epidermal cells. Okay, so it is the general structure of the dicot stomata. Okay, if we study the monocot stomata, the monocot stomata, it has the two guard cells, the bell-shaped guard cells. Okay, and they have no, or this dumbbell-shaped cell, they have no chloroplast with the starch. Okay, that means they do not have the starch in their guard cell. So it is the monocot. Okay, it is the monocot stomata and it is the dicot stomata. Okay, so how the opening and closing of this stomata takes place, it is studied under the mechanism. Okay, so the first of all, the scientist own Mohel, the scientist own Mohel in 1856. On Mohel in 1856, he proposed that the stomata open in open in light stomata open in light and closed in dark. Okay, and he explained this movement of the stomata, that is open in light and closed in dark, which is on the basis of the photosynthesis in the guard cells. Okay, so when there is the photosynthesis takes place, the stomata open when during the daytime, and when photosynthesis stops, it is closed during the night time. Okay, so the next scientist, that is the Syre, Syre, Syre. In 1926, the scientist Syre, he observed that the stomata is open in neutral or alkaline pH. Okay, so the stomata is open in neutral or alkaline pH. Alkaline pH. That means even though there is the darkness, okay, even though there is a darkness, then also, if there is a neutral or alkaline pH, so or the stable pH or alkaline pH, then the stomata it gets open. Okay, that means the one Mohel, he stated that the stomata is open in the light. Okay, but according to Cyrus, stomata open in neutral and alkaline pH, that is the 7 or the more. Okay, that means there is, even though there may be the darkness or there may be the light. Okay, then also, and it is closed in acidic pH. Closed in acidic pH, and that acidic pH, it is the 5. Okay, that means even there is a light, even there is a light, then also if the acidic pH is 5, then stomata get closed. Okay, and even though in the dark, when the pH of the guard cell is neutral or alkaline, then the stomata gets open. Okay. So this theory it is known as it is known as the starch sugar interconversion. This theory is known as the starch sugar interconversion. Starch sugar interconversion. Okay, that means the starch is converted into sugar and sugar is converted into the starch. The sugar means particularly the glucose. Okay, sugar means particularly the glucose. Okay, okay, and then the scientist Stark Stark GW in 1932 he elaborated this theory, and that is the starch sugar interconversion theory. Okay, so there are the two basic mechanisms of opening and closing of stomata, and these are known as the two popular theories that explain, okay, the opening and closing of stomata. So the one most important uh, theory for the opening and closing of stomata it is given by the scientist Steward. Steward. So it is known as the Steward's hypothesis. This Steward hypothesis it is in 1964. He proposed his early theory is proposed in the 1964. So this theory is also the sugar, or it is also the starch and the sugar interconversion theory, but it is modified. Okay, so it is the modified starch and sugar interconversion theory. Okay, so according to him, when the starch is converted into when the starch is converted into the glucose 1 phosphate. Okay, glucose 1 phosphate. So this that means first of all the starch is then directly converted into the glucose. First it converted into glucose 1 phosphate. Okay. So this glucose 1 phosphate is osmotically it is inactive. Okay, it is inactive. And when this glucose 1 phosphate is converted into this glucose 1 phosphate is converted into the glucose 6 phosphate, and after that the phosphate is get released and it convert glucose 6 phosphate into glucose and inorganic phosphate. Then this glucose is osmotically active. It is osmotically it is osmotically active. Okay, and this increases the osmotic pressure of the guard cells. Okay, guard cells, and so there is interconversion of starch into glucose. It is most important. When this glucose is produced, it is the guard cells it becomes osmotically active, and therefore they are able to absorb the water from the surrounding cells. And when they absorb the water, then they get sweat. Okay, we will explain it after some time. Then, according to him, there is a metabolic energy in the form of ATP. The metabolic energy in the form of ATP is also required. This ATP is also required for the closure of the stomata. That means it is required for the opening of the stomata. It is for opening of the stomata, and the metabolic energy ATP or the respiratory energy or this ATP which is produced in the respiration. It is necessary for the closing of the stomata. So O2 is required, and the CO2 it is accumulated it becomes osmotically inactive. Okay, so O2 which is utilized in the respiration it is important for the closing of the stomata. Okay, so what is the Steward hypothesis actually? So according to this theory, during the daytime the starch becomes soluble. Okay, during daytime what happens when there is a daytime the starch it becomes soluble. The starch it becomes soluble. Okay, and it converted into the soluble sugars. Okay, it becomes the soluble sugars, or it converts into the soluble sugars. Okay, and it is with the help of enzyme. That enzyme is known as the phosphorylase enzyme. It is with the help of phosphorylase enzyme, or we will draw here the starch in presence of the organic phosphate, that is IP. Okay, so starch in presence of organic phosphate and the enzyme, that is the phosphorylase. Enzyme phosphorylase at the pH 7 or at the pH alkaline. It converts into glucose 1 phosphate. It converts into glucose 1 phosphate. Okay. So this glucose 1 phosphate which is produced here, it is not osmotically active. So we can say that it is osmotically inactive. So the chloroplast of the guard cell which have the starch in presence of the inorganic phosphate and the enzyme phosphorylase at the pH neutral or alkaline, it converts into glucose 1 phosphate. Okay, but this glucose 1 phosphate is osmotically inactive. So it osmotically inactive, therefore it do not occur any changes in the guard cells. Okay, but later on what happens? This glucose 1 phosphate, this glucose 1 phosphate, this glucose 1 phosphate in presence of enzyme phosphoglucomutase, phosphoglucomutase, in presence of phosphoglucomutase as well as the pH 5. Okay, pH 5. So this glucose phosphoglucomutase is convert into glucose 6 phosphate. Okay, it convert into glucose 6 phosphate, and then this glucose 6 phosphate in presence of enzyme phosphatase, in presence of enzyme phosphatase, what happens? This glucose 6 phosphate is converted into glucose and the inorganic phosphate. Okay, so this interconversion in the guard cell, that means the starch which was insoluble, it convert into the soluble form, and that soluble form, that is the soluble sugar. So how the soluble sugars converts? The starch in presence of the phosphate, inorganic phosphate, and the enzyme phosphorylase at pH 7 is converted into glucose 1 phosphate, but glucose 1 phosphate is osmotically inactive. So it is osmotically inactive means it do not occur or there is no any changes take place in the guard cells. Okay, that means it behave as like the starch. There is no any effect of the conversion of starch into glucose 1 phosphate. But when the glucose 1 phosphate in presence of enzyme phosphoglucomutase, the pH at pH 5 is converted into glucose 6 phosphate. Okay. So this glucose 6 phosphate in presence of enzyme phosphatase, it converts into the glucose and the inorganic phosphate. Now this glucose is osmotically active. It is osmotically active. Osmotically active means what happens? When this glucose it is produced in the guard cells, So what happens? So it increases the osmotic pressure of the guard seal. Okay, it increases osmotic pressure of the guard seal. In first year we already studied about the osmotic pressure or the DPD, OP, etc. Okay, osmotic pressure, diffusion pressure deficit. So this glucose, it is osmotically active, means it increases the DPD and the osmotic pressure of the guard seal, and due to the increase in osmotic pressure and diffusion pressure deficit of guard cell guard cells, what happens? Then guard cells, they take water from surrounding, they take water they take water from surrounding. Okay, and due to that what happens? The wall, which are thin. Okay, so when it absorbs the water, this after absorption of the water, this wall, it get fully, these two guard cells, they get fully turgid. Okay, these guard cells, they get turgid. Turgid means what? When the cells, they absorb the water, they swell in size. Okay, and they develop the pressure, or the wall gets stretched due to the accumulation of the water, and that pressure is known as the turgid pressure. मागच्या वर्षी आपण पाहिलेलं आहे turgid pressure म्हणजे काय, की एखादी पेशी जेव्हा त्या ठिकाणी वॉटर ऍब्सॉर्ब करते ती फुल्ली स्ट्रेच होते, आणि त्या कंडिशनला, त्या प्रेशरला त्या ठिकाणी काय म्हटलं जातं? Turgid pressure. So the glucose, which is produced from the interconversion of the starch, which are present in the chloroplast of the guard cells, so it converts into the glucose. This glucose is osmotically active, so it increases the osmotic potential and diffusion pressure deficit of these guard cells. Due to that, it absorbs the water from the surroundings, and when this absorbs the water, this wall gets stretched out. This guard cells, the wall of these guard cells, they are stretched out. Okay, and due to that stretching, what happens? This pore, it get open. Okay, so it get pore, stomata get open. Stomata get open. Okay, but later on, okay, what happens when the glucose plus, according to Steward, okay, the glucose during, particularly during the night time, the glucose plus ATP, so respiratory energy is required here. So for that purpose, the oxygen is also required. So this ATP, in presence of the enzyme hexokinase, the glucose is converted into glucose 1 phosphate again. Okay, so during the night time, what happens? During the night time, this glucose is converted into the glucose 1 phosphate. That means by the presence of enzyme, that is the hexokinase. Then this glucose 1 phosphate, is converted into the and starch and phosphate and in presence of the enzyme, that is phosphorylase, in presence of enzyme phosphorylase, so it converts starch and phosphate, glucose 1 phosphate converted into starch and phosphate. So this starch, it is osmotically inactive, and therefore it reduces the DPD. It reduces DPD as well as osmotic pressure of the guard cells. Okay, and when this DPD of or osmotic potential of the guard cells, it gets reduced, Then the wall which was stretched, okay, so they loses water outside. They loses water outside, okay. And due to that what happens? This wall it gets flaccid. This wall gets flaccid. And due to that these walls they collapse above one another. The wall of the guard cells they collapse above one another, and therefore the stomata get closed. Stomata get closed. Okay. So it is the mechanism by means of which the opening and closing of the stomata takes place. We will draw here one figure, one flow chart we will draw here. The starch plus inorganic phosphate. Okay. So in pH 7, when there is a pH is equal to 7 or alkaline. So in presence of enzyme phosphorylase, phosphorylase. So it converts into glucose 1 phosphate. Glucose 1 phosphate. Okay. So the glucose 1 phosphate in presence of the enzyme phosphoglucomutase. Phosphoglucomutase. Okay, in presence of phosphoglucomutase, so it converts it into the glucose 6 phosphate. It converts it into glucose 6 phosphate. So the in presence of enzyme phosphatase, there is a release of one inorganic phosphate and it converts into the glucose. It converts it into the glucose. Okay. So it is all this cycle. This takes place during the daytime. So the stomata open. Stomata open and this time is the daytime. Okay. So at the early in the morning, the starch is converted into the glucose phosphate, glucose phosphate and the glucose. In presence of the enzymes like phosphorylase, phosphoglucometase and here the phosphatase. Here the enzyme phosphate in presence of enzyme phosphatase. So glucose is produced which is osmotically active, therefore it absorbs the water, wall of the gut cells gets stretched and the stomata get open during the daytime. During the night time what happens? During the night time there is only the respiration, there is no photosynthesis. Okay. There is no photosynthesis, only the respiration. So there is the accumulation of CO2 in the gut cells. And when there is accumulation of CO2, the CO2 gets accumulated during the night time. Okay. There is because there is no photosynthesis. So during the respiration the CO2 is released and that CO2 is not utilized in the process of the photosynthesis. Okay. So and O2 is utilized in the process of respiration. So in this process, the respiration which is utilized the O2, that is the respiration. Okay, respiration. But there is no photosynthesis, therefore during the process of respiration, the CO2 which is released, it is accumulated there and therefore it reduces the pH. It reduces the pH. Okay. So in that reduced pH, in presence of enzyme hexokinase, In presence of enzyme hexokinase, this ATP is converted into ADP. That means there is utilization of ATP. Okay. ATP is converted into the ADP in presence of the enzyme hexokinase and it converts it into the glucose 1 phosphate. Glucose 1 phosphate, it is at the, this process takes place at the pH 5. It is at the pH 5. Now why this pH 5 is produced here? Because in the respiration CO2 is released, okay, and O2 is utilized. So this releases CO2 is accumulated, produces the acidic condition. Therefore, when the pH becomes 5 in presence of enzyme phosphorylase, in presence of enzyme phosphorylase, this glucose 1 phosphate is again converted into the starch and the inorganic phosphate. Okay, so this starch is osmotically again inactive and therefore it reduces the osmotic potential and diffusion pressure deficit of the guard cell, and due to that the water, it goes out from the guard cells, and as the water goes out from the guard cells become flaccid, and the thick inner wall of the guard cells, they collapse on one another and the stomata get closed. So here the closed stomata. So this takes place during the night time. This takes place during the night time. Okay. So this scheme, it is known as, this scheme is known as the Steward's, it is known as Steward's hypothesis. Okay. But there are some limitations or objections to the Steward's theory. So what are that objections? Objections to that theory. Some regard says, especially that the monocots, they do not have the starch. First of all, monocots do not have starch. Do not have a starch. But then also the opening and closing of stomata takes place. Then also the opening and closing of stomata takes place. Opening and closing of stomata takes place. Okay, this is the first objection. It is the first objection. Monocot do not have, or monocot stomata do not have a starch, and then also the opening and closing of stomata takes place. Okay. Then second objection, it has been observed that the stomata remain closed at midday also without any change. Okay. It has been observed that the stomata often sometimes stomata may remain closed, often remain closed during the midday. म्हणजे दिवसाच्या मध्यभागी सुद्धा कधी कधी स्टोमॅटो हा क्लोज असतो. ओके, midday without any change in the starch. Without any change in starch. Without any change in starch. Okay. Then the third objection to this theory, third objection, according to this theory, the ATPs are utilized. According to theory, the ATPs are required or utilized. Required, but it is not the case. But it does not require. it does not require. Okay, that means for opening and closing of stomata, ATP does not require. Okay, then the next objection, at some instances, starch is formed at pH found during the opening of the stomata. Okay, sometimes what happens? Sometimes, sometimes the starch is formed at a pH found. The starch is formed. The starch is formed at a pH found at a pH found during the opening of stomata. During the opening of the stomata. Stomata. That we know that the starch is present, it converts into the glucose, then only opening of the stomata takes place. Okay. And when the stomata is open, there is the presence of the glucose. But it is observed that sometimes starch is formed at a pH found during the opening of the stomata. That means the starch is also produced at pH 7. Even if there is no acidic pH, then also the starch is there produced. Okay, the last one, it fails to explain the effect of blue light on stomatal abdomen. Okay, it fails, this theory fails to explain the effect of blue light. The effect of blue light in opening of stomata. In opening of the stomata. So these are the certain objections. The first, that is monocot, do not have the starch, and then also the opening and closing of stomata takes place. Second, the stomata often remain closed during the midday also. Okay, midday also without any change in the starch. म्हणजे स्टार्च मध्ये कुठलाही बदल नसताना दिवसामध्ये सुद्धा ऐन दिवसाच्या मध्यात सुद्धा स्टोमॅटा हा क्लोज असतो. म्हणजे दिवसा लाईट मध्ये किंवा दिवसा स्टोमॅटा ओपनच आहे असं काही नाही. ही कंडिशन कधी कधी बदलते. ATP कधी कधी the ATP they are required, but it is not the case. Okay, म्हणजे ATP लागतच नाही, पण यांच्या मानण्यानुसार रेस्पिरेटरी एनर्जी लागते ATP. Sometimes starch is formed at a pH found during the opening of the stomata. म्हणजे ज्यावेळेस स्टोमॅटा ओपन झाला असते, अल्कलाइन पीएच असतो, त्यावेळेस म्हणजे स्टार्च कन्वर्जन ग्लुकोज मध्ये झालेला असतो. सो तो जो पीएच आहे दॅट इज द सेमन पीएच. तर कधी कधी या ठिकाणी काय होतं की समटाइम्स स्टार्च इज फॉर्म्ड ॲट अ पीएच फाउंड ड्युरिंग द ओपनिंग ऑफ द स्टोमॅटा. म्हणजे तो त्या ठिकाणी 5 असायच्या ऐवजी कधी कधी 7ही त्या ठिकाणी पीएच असतो. आणि इट फेल टू एक्सप्लेन द इफेक्ट ऑफ ब्ल्यू लाईट इन ओपनिंग ऑफ द स्टोमॅटा. असं म्हटलं जातं की ब्ल्यू लाईटमध्ये स्टोमॅटा ओपन होतो. तर त्या बाबतीमध्ये ही थेअरी काहीच सांगत नाही. ओके, सो दिस थेअरी इज गेट रिजेक्टेड. This theory is get rejected. I hope you got the point. Thank you very much.